Welcome to the Data Hall YouTube channel. In this video, we are going to discuss the if qualifier, the in qualifier, and the by prefix that is used in Stata. Now, although these two are qualifiers and this is a prefix, but these three are used to separate data, and that's why we have clubbed them together in a single video. We would start with the if qualifier, and when we say qualifier, it means that what it would do is that it would perform a command on some subsection of the data, right? So the same is the case with the if, in, and by. They all perform certain command on a specific section or subsection of the data. So within if, we have two options. Either we can use the if qualifier or we can use the if statement. We would come back to if statement later on, but let's start with if qualifier. Now for that, we need to import a data set. So we go with our traditional data that we use quite commonly. We click on File, Example Data, and we install the pre-installed, or we import the pre-installed data, which is the auto data. So we have the data in our Stata memory. So there are multiple variables and we are going to work with the data view. So as we apply the command, we can quickly see the results, how this command would work. So to remove some clutters, what I would do is I would work with just the price and the repair variable. So let's uncheck all these boxes which we are the variables which we are not going to work with. So it would remove them from the data view and we would just be able to look into these two variables and the variables we are going to generate. Okay, so let's bring our do file that we have created, and let's start with the if statement or the if qualifier. What this if would do is that it would perform certain command on a specific subset of the data. So for example, in this case, we are asking Stata to generate a variable d1 and assign it a value of 1 if the repair 78 variable is equal to 3. So if this variable would have a value of 3, a new variable would be generated, and whenever we have 3 in repair 78 variable, we would have a value of 1 in the d1 variable. So let's run this and we would see that we have repair equal to 3 and we have the d1 would be equal to 1. So as the condition would be met, so what if would do is that after if statement we would have certain condition, and if that condition is met, then that specific command would be executed. So in this case, this repair 78 variable is not equal to 3. It is different than 3. So this whatever command we wanted it to execute was not executed and it didn't got the value of 1. So let's come back here, and what we have is, once we use the if qualifier, then the if statement would need 3 information. First is the variable that we want to perform certain task on. Then we would need a logical operator, and I have made a whole video on this logical operators. I would give the link in the description. You can check that video. It would give you a quite good idea of what logical operators we can use in Stata. And then we would need a value or a second variable, right? So these are the 3 components that are needed with the if qualifier. So in simple words, after the if qualifier, we use a condition. If that condition is met, then this specific command would be executed. Now it is not necessary that we use this if with just the generate command. We can use it with a lot of different commands, and this if and in qualifier is it can be used with multiple commands. So let's do this one. We want to summarize only the values where the price variable is greater than 6,000. So if I execute this command and let me bring back the results window, you would see that summarize if price variable is greater than 6,000. The total number of observations are 74 in our data, but in results we are not getting 74 observations, rather we are just getting around 23 observations. And the reason is that for these 23 observations, price variable had a value of greater than 6,000. Okay, so we can use it with multiple commands. Let's do one more. Let's generate. I would mainly be using the generate, because the idea is that as I use generate, and the result of the command would be viewable in this data window, and we would I think it is easy to learn the command when you know what it is going to do. So generate D2, it would be equal to 1 if the repair 78 variable is greater than 3. Now there is an issue. Let's come back over here. You would see that if this condition is met, the repair 78 variable is greater than 3, D2 would have a value of 1, right? It is correct for these cases, but what about this one? In this case, the repair 78 variable is missing, but still we are getting a value of 1 in the D2 variable. So there is something wrong with the way our command executed, and the reason is that in Stata, what Stata do is that internally it assign a quite high value to the missing values, right? So if there is a missing value, it would assign certain high value to it, and when we would use this condition of greater than some number, the missing values would also be included in this condition. This condition would also work for the missing values. Why? Because internally those missing values would have a quite high value, right? So what we need to do is we need to explicitly tell Stata that do not execute this command if the repair 78 variable have a missing value. So in this case, previously we have seen all the examples where we just have one condition, but now we are going to apply more than one condition. So let's generate a D3 variable. It is till this part, the equation or the command is same as before, except now we are going to use AND logical operator. Again, you can go back and watch the logical operator video, and we are saying that if the repair 78 variable is not missing, this exclamation mark is used for not, and then we have a missing function. So now if we execute this, there would be a new variable of D3. Now you would see that here the repair 78 variable have a value of 4. So the result for D2 and D3 is similar. But what about these missing values? It won't execute this command for them when the repair 78 have a missing value. And why is that so? The reason is that we have used the AND logical operator. What this AND would do is it would check if this condition is met, and would also check if this condition is met. Once these both conditions are met, these both conditions are true, then it would perform this task. Then it would assign a value of 1 to the D3 variable, right? So we are using multiple conditions. There is one more way where we can use multiple conditions. Let's just say we just do not want it to, we also want that do not generate D4 variable, do not assign a value of 1 to it if the repair 78 and price both have missing values. So in this case, within the missing values, parentheses, we are assigning, giving two variables. So these both shouldn't have missing values. Although in our data, the price do not have any missing values, but you can use this command, right? So it would generate D4 for our data, D3 and D4 would exactly be same, but for your case, it might be different. Okay, let me give you one more example. Let's generate a D5 variable, assign it a value of 1. If the repair 78 is exactly equal to 3, and now this part is similar to before, so we need to have both these conditions met for Stata to assign a value of 1 to D5. But now within parentheses we have further two conditions, and it is separated by OR. You know, this sign is used for the OR logical operator in Stata. So what it is saying is that if price is less than 4,000 or price is greater than 10,000, for both these cases, so this is an OR, right? So for both these cases, when the price is less than 4,000 or the price variable is greater than 10,000, if this condition is met, then what Stata would do is check this condition and to see if repair variable have a value of 3. Then it would assign value of 1 to the D5 variable. Let's execute this and see how it works. Okay, let me first sort the price variable. Okay, so we can, I hope, sort it. Okay, let me sort it from the command window. So sort price, so this way we would be able to easily get an idea. So these are the values from first line to 11th line. These are the values where the price variable is less than 4,000, right? But they all do not have a value of 1, because although one condition is met, but the second condition of repair 78 being equal to 3 is not met for these cases. But where it is met, for example in line 1 and 3, both the conditions are met. The price is less than 4,000 and the repair is also equal to 3, so we have a value of 1. Let's scroll down to the area where the price is greater than 10,000. The similar is the pattern over here. If the price is greater than 10,000 and the repair is equal to 3, then we would see a value of 1 in the D5 variable. So I hope you have got the idea. But what these parentheses are doing here is that, as we would see in mathematics, whenever we have parentheses, we would first have to solve the parentheses. The same is the case with Stata. What Stata would do is first it would solve the parentheses. It would see either of these conditions being met, and it would assign a value of true or false to this specific part of the equation. So if this is met, so whenever the price was greater than 10,000, the second condition was met, or whenever the price was less than 4,000, the second condition was met for these values. But for all these values greater than 4,000 and less than 10,000, this part of the equation do not match, this condition do not match, so it would have a value of false. Then it would move forward to the second condition. It would assign a value of true or false. Once these two, because we are using AND operator, so these two values should be true for this command to be executed. I hope I'm not complicated it further, but I have simplified it over here. If we are using the OR operator, as in this case, so when would this condition be true? It would be true if both of the conditions are true, right? That is, price is less than 4,000 and it is also less than 10,000. In our case, it won't happen. When the first condition is true but the second is false, again this whole criteria would be met. When first is false and the second is true, again this whole criteria would be met. The only case where this whole condition would be false is when both the criteria are not met. That is, the price is not less than 4 or it is not greater than 10,000, which I have just shown in this case. The highlighted part is the part where this condition is not met. Then what is the case with the AND operator? Remember, we are using AND operator here. It would only have a value of true. This condition would only be satisfied and the command would only be executed when both the conditions are true. So when the first condition is true and the second condition is true, then this command would be executed if we are using the AND operator. In all other cases, it would not be executed. It would have a false value. Okay, one last thing is that the if qualifier cannot be used after the options. You remember, for every command we have certain options and we input the options after the comma. So in case of Stata, we have to use this if qualifier before the comma. So if you are using this if statement after the comma, you would get an error. It is a wrong way of inputting the if qualifier. It should always be before the comma, before the options. Okay, let's move to our second part, which is the if statement. Now first, what is the difference between if statement and if qualifier? Or rather, let me just go through these statements and then it would be easy for you to grasp the idea. Before that, let me remove this D1 to D5 variable from the data window. How we do that? We select all these variables from the variable panel. We would simply uncheck them and we have removed them. Okay. Now we are doing something similar to the first condition or first statement that we executed. We generated a variable, assigned a value of 1 if the repair 78 variable had a value of 3. Let's do the same over here. We are saying that if repair 78 variable, or the repair variable, rather than saying repair 78, it would be easy if I say repair, have a value of 3, then I want to generate a D6 variable and assign it a value of 1. If it isn't 3, then there shouldn't be any value. Okay, let's execute this. Okay, so this is quite, interesting. We are getting values of 1 for the D6 variable, irrespective whether the repair 78 is 3 or not, right? So it is executing the command, but somehow it is not executing the way that we want it to do. Let's do it one more time. Let's say if repair 78 is equal to 4, then we want D7 variable having value of 1. Let's execute it. It is executing the command but not generating any variable. Now let's understand the reason why is that so. What this if statement is doing is it is just looking at the first value of this variable, and if the condition is met, it would execute the command given within the parenthesis, within this curly bracket. So we just have one command in this curly bracket. We can have multiple commands. So what happened is that repair 78 have the value of 3 for the first row, for the first instance, right? So it executed the command. The condition was met, and once the condition is met, whatever command we have within these curly brackets, it would be executed. But in case of the second command, we wanted it to execute this, but it checked that repair 78 do not have a value of 4. So it didn't execute the command. So what it is doing is that the if statement would just look at if we use the variable name, it would just look at the first value of the variable. But instead, what the if qualifier would do, as we have done previously, it would execute the command for each line one by one, checking the condition whether that condition is met or not. So when we are working with variables, the if qualifier is the right way to go, right? It is quite uncommon to use if statement with variables. So if you are working with variables, you have a data in columns in a variable in Stata, then if qualifier is the way to go. So in case of if statement, the whole block is of the commands is either executed or it is not executed. And we should use if statement when we have a constant number, right? Or we have a constant and we do not depend on a variable, right? So in that case, this if statement would be a perfect way to go forward. Let me give you an example. Let's summarize. Let's move to the result window. Let's summarize this price. What this summarize command would do is it would give us a bunch of descriptive statistics. Whenever a command is executed, it gives us a result on the result window. It stores the value in some macros, what we call, or a local variable, a variable which are not shown in this data by itself. We can check that by using the command return list, and it would tell us that this number of observations are stored in this specific scalar. Then the mean value is stored in this variable or scalar. It isn't shown in the variable window. The minimum is stored in R minimum, so on and so forth. And we can use these, we can refer to these numbers. So now in this case, it is a constant number. It won't change, right? It isn't a variable. Now it might be a good idea to use the if statement. So let's say if this Rn, which stores the value of number of observations, is equal to 74. We know in this R case we have 74 observations. We want to generate a variable d1 which would be equal to 1. Let me bring the data view. Let's execute this command. So because the summarize, when we executed summarize, the Rn scalar had the value of 74. We can see it from here. It had a value of 74, so the condition is met and the command was executed and the new variable was generated by the name of d1 and it had a value of 1. But let's say this command is not executed, right? Let's give it a value of 75, an incorrect value, so the condition does not met. What we can do is, with if statement, we can also use the else statement. So now we want that if this condition is not met, if first it would check if the condition is met. If it is met, it would execute this command which is within these curly brackets, and if it isn't met, then it would move towards the else block, and it would execute the command that is within these curly brackets. So let's so now we know that condition wouldn't be met because we just have 74 observation and we are giving purposefully a wrong condition. We have got an ABC variable. Why? Because this code wasn't executed, rather it checked that Rn is not equal to 75. It simply skipped these commands and jumped to the else command, right? So this is how we use the if statement. I hope it was quite easy for you to understand. So let's move towards the in statement, and again, before doing that, let's remove these values from the data view. We aren't deleting them, we are just removing them from our view. So we have this in qualifier. So this in qualifier, what it would do is that it would be executed on the rows of the data. Okay, so let me generate a new variable d9, assign it a value of 1, just in the row of 5. Okay, so it didn't had any condition other than that it should be in row 5. The value should be in row 5. We can also use as with the if statement, we can use in with multiple commands. So we can simply list is would just give us the price variable. Let me execute this. Let's execute the second command, list price in 10. So whatever the price is in the 10th row, it would be shown in the result window. I can show you from the data view that this 10th row had the value of 3984, and that is what we have over here. Or we can list price if within the first 10 rows of the our data set. So again, we would get back to our generate command, and instead of moving towards the result view, we would use the data view to work with our command and try to understand how it works. So generate D10 variable, assign it a value of 1. So it is not necessary that we would always start with a number. We can just use the word, the alphabet F, and F stands for the first value. So it would start from the first value and end till 15. So, or we can, if we are running the regression or summary statistics, we can do summarize price variable in first 15 observations. That would also work. If we are using regression, we can also limit the data, right? We can, it is not necessary to always start with the first observation. We can start with the 5th or any number of observations. So in this case, we are going to start with the 5th observation and till 15th observation. Or we can, start with the 50th observation and move towards the last. So I'm using L over here. It would be small cap L. So this command would only assign a value of 1 if in the rows of 50 till the last row. Or we can do it like this, that generate a D13 variable, assign it a value of 1 in the last row and 5 values before the last row, right? Again, let me scroll down. So just 5 values before the last line. And here we can generate, D14 variable, assign it a value of 1 in, last 5 to last, second last values. So somewhat similar to the previous command, except that instead of assigning it a value till last row, we want it till the second last row. Last item on the list is the by prefix. Whenever we are writing something before the colon, we are using prefix, right? So what this would do is, let's say we want to summarize the price variable, and for this we would have to move to the results window. We want to summarize the price variable, but we know in our data set we have a variable of foreign, which says that whether a car is manufactured locally or it is manufactured in a foreign country. We do not want summary statistics for all the cars together. We want it separated by either the car is domestic or a foreign. So we use Bysort, the foreign variable name, colon, and then the command. Again, this can be used with multiple commands. So we are executing this summarize command for different subset of the data. So we get this price summary statistics if the car is domestic, and this price summary statistics if the car is foreign. We know there are 52 domestic cars and 22 foreign cars. The mean value of domestic car is 6,000 and the mean value of foreign car is 6,300. So foreign cars are somewhat expensive as compared to the local cars. But within Bysort, we have, again, we can either use just by within, we can exclude this sort. Let's say if we didn't want it to sort the data first. So what this command is doing is that it would first sort on the basis of foreign variable and then execute this command, right? We cannot use this by before sorting the data. So this command is sorting the data based on foreign variable and then executing the command. But in this case, we do not want the data to be sorted. Let's see what happens. We are getting the same result as before. So why we have two different commands? To get the idea, we first have to let's distort the sorting of the data. The data is already sorted on the foreign variable. Let me show you from the data view. So let me bring the foreign variable, and you can see we have all the domestic cars at the top, and then we have the foreign cars at the bottom. So the data is already sorted. So let's distort the sorting of the data. Let's sort it on some other variable other than the foreign variable. Let's sort it on, let's say, price. And now let's see what happens to the data. Now the data isn't sorted on the foreign variable. Okay, so let's say we wanted to execute this command now. It would give us an error saying that the data is not sorted. Why is that? So we won't be able to run this sort command, this by command, this by prefix, without first sorting the data. So then why do we have this by? The reason is that sometimes we want to run multiple by commands, and sometimes we have a large data set. Using this by sort, what it would do is it would always sort the data first and then execute the command. And for large data sets, it can be time consuming command. For large data set, what we can do is we can simply use one command and sort it once based on foreign variable, and then we can have multiple commands. Let's just say we can use mpg over here. So now in each of these commands, we wouldn't have to first, this data wouldn't have to first sort it. It would simply be easy to execute. It would be efficient to execute these commands. So if you have large data set, first sort it on the variable of interest and then use whatever multiple commands you are going to use. If you are just going to use one by sort command, then it doesn't matter. Oh, one more thing, you can rather use sort also over here. So this command is exactly similar to this command. Why? Because it is, it is having an option of sort, and what it is doing is that before using the summarize command, it is sorting on the foreign variable. So that's it for now. I hope you enjoyed the video.